what I'm trying to do is quite foolhardy because there are so many experts in the audience, especially Guido and Federico and other people. So I'm trying to offer some ideas here, so please do not hesitate to criticize me. The motivation is, it seems to me there is a swinging pendulum. I mean, there's a lot of very authoritative philosophers and physicists that basically thought that the job had been done. And Gell-Mann, for instance, has just changed his mind about this, and he said, we have been brainwashed by the community of physicists into thinking that the job had been done. And then I think there is another quotation here which I skipped, but Bell said that Bohr, loved to revel in contradictions. And I think that it's the right moment to try to come up with a more balanced evaluation. This is something that I notice in reading Bohr. There are these two sort of conflicting theses. The essential new feature, I'm quoting from On Atomic Physics and Human Knowledge, the essential new feature in the analysis of quantum phenomena is, however, the introduction of a fundamental distinction, I'm going to use this acronym here, between the measuring apparatus and the objects under investigation. But then we find, in this great paper where I think he expresses all of his ideas, accordingly, an independent reality in the ordinary physical sense can neither be ascribed to the phenomena nor to the agency of observation. And then the question is, how can a classical object be distinct from a quantum entity if it does not possess an independent reality? That's my question. And this is the plan. I wanted to try to summarize in a very ambitious way what the current situation of the philosophy of QM is, and then the source of the conflict that I just presented, which I think it derives from the quantum postulate. 5 difficulties raised by an ontological reading of the distinction thesis, and then I will try to defend Bohr as much as I can, given my limited knowledge, by listening these sort of responses, like some sort of neo-Kantism that has been already discussed, the idea that Bohr basically relied on this descriptive metaphysics, the solution by decoherence. I'm not going to go into that, and what I'm going to baptize the part strategy, which is the idea that you can always think that there is a part of a classical system that really is entangled with a quantum system, and that some scholars think would be a solution to the problem. And then this is my point. I want to insist that you can have 2 different explanations in physical theories. One is a sort of principled theory explanation, and the other one is a constructive theory explanation, although everybody, I think, is quite familiar with this 1919 paper. I'm just quickly reading it. The kinetic theory of gases seeks to reduce mechanical, thermal, and diffusional processes to motions or movements of molecules, i.e. to build them out of the hypothesis of molecular motion. When we say that we have succeeded in understanding a group of natural processes, we invariably mean that constructive theory has been found, which covers the processes in question. I'm trying to dispute this, at least in a very humble way. The elements, this is the definition that Einstein gave of the principled theories, the elements which form their basis and starting point are not hypothetical constructed, but empirical discovered ones, general characteristic of natural processes, and of course, the science of thermodynamics seeks by analytical means, by axiomatization, basically, to deduce necessary conditions. And the theory of relativity belongs to the latter class, because Einstein was really worried about what could be a conflict within the situation in physics, because on the one hand, you have this continuous idea of propagating electromagnetic waves, but then, of course, he knows that there is a discrete element. So he doesn't know how to solve that, and he goes by this very interesting move. And this is my very ambitious attempt to reconstruct what's happening today, you have theories of principle according to which Qt is a new theory of probability deriving either from the theory's mathematical structure or from the structure of information. And then there is this more constructive camp where, using Bell's approach, I mean, the wave function is either not everything or is wrong. So you have either Bohm or GRW tens. And the constructive theory tries to postulate beables, things that just exist in space-time or on-tip wave function, where the main protagonist of the ontology is this 3n configuration space. And the claim is that he tried to solve the conflict by invoking Einstein's principal theory approach to STR. My claim is that 1 and 2 reflect two stances toward the aim of science that are not incompatible. The same theory can be given both principal type explanation by axiomatizing the theory, by unifying the phenomenon, and constructive explanations. So, what is a stance? I just read this great book by my friend Engin. An epistemic stance is an orientation, a collection of attitudes, values, aims, and other commitments relevant to thinking about scientific ontology. The idea of a stance comes really from Van Frassen, who wrote about the empirical stance. Now, the source of the conflict, in my opinion, is the quantum postulate, which I will assimilate to the principle of relativity. These are, for me, the four related consequences. This is, I think, the main expression of Bohr's philosophy. The quantum postulate attributes to any atomic process an essential discontinuity of a rather individuality completely foreign to classical theories and symbolized by Planck's quantum of action. And I think it's fair to say, Guido will correct me, that a new form of individuality is really a consequence of this discontinuity, which, in a sort of approximate definition, we could call a new form of atomism, where the atomistic aspect has to do with discretization of action. And it's a new form of holism, which is what I'm trying to explain here, nonseparability between quantum systems and classical apparatuses, which I think he interprets as a non-tick hypothesis, which he calls no independent reality. The characteristic new feature of quantum physics is merely the restricted divisibility of the phenomena, which, for unambiguous description, demands a specification, what does it mean here, of all significant parts of the experimental arrangement. It seems to me that when he refers to specification, it's just after a conceptual approach, but there it seems to me that he's insisting on a non-tick. And this is something that I use as a metaphor. Due to the principle of restricted divisibility, H is like a glue belonging to both S, the system, and the apparatus. And there's another principle that follows from the quantum postulate. It implies that any observation of atomic phenomena will involve an interaction with the agency observation, not to be neglected, which for Bohr means no pre-existing value. There's no idea of disturbing something, which presupposes that the something you're interacting with has already value. And here is the first reference to the special theory of relativity. Unlike coordinate-free point events, which are the objective element in relativity, there's a point coincidence argument that Einstein used afterwards, a renunciation as regard to causal space-time coordination of atomic processes. When did I start, Harald?
We started 12:40-ish.
Okay, so please tell me when 10 minutes are left, because I know you're all hungry. So there is some sort of interesting connection between the quantum postulate. Let me claim, for instance, if you want to define a state, you have to assume that this state or system is completely separable from the rest of the environment, And then you can give the spatial temporal coordinates. But let me go through these 5 difficulties of an ontological separation. This is the well-known Bohr's picture, the shifty split problem. Where and how do we draw a boundary between the quantum and the classical, given that there is a quantum, that quantum phenomena are macroscopic and they inhabit the meso or even the macro scale. So here's before the apparatus, after the apparatus, the brain of the observer, and then the mind of the observer. The second difficulty here, I think, is a consequence of this famous exchange between Einstein and Bohr. So I have to prepare somehow you to this consequence. As you all know, by conservation of momentum, Einstein thought that by measuring the upward or downward motion of S1, after the particle went through, we can know which slit the particle crossed without destroying the interference pattern. He was not after the project of criticizing Heisenberg here, because I think he wrote to Pauli or Bohr, a letter in which he said, I don't care here about trying to criticize. And this is the relevant response. Bohr says, if you want to measure the motion of S1, you need to have an exact determination of its vertical motion, which entails an indeterminateness of its position. So the idea here is that he's claiming that this big stuff is a quantum object. So, as Federico claimed, Bohm is a universalist about quantum theory. Then, of course, the problem is I want to skip this because you're all familiar with this problem. I mean, Bohr here uses a solution which I think is quite reasonable. The concept of observation is insofar arbitrary as it depends upon which objects are included in the system to be observed. And this is really an instrumentalist approach, which I think Bohr was not really after. The whole purpose of the formalism of quantum theory is to derive expectations for observation obtained under given experimental conditions. So there is this sort of very pragmatic attitude, according to which now it seems that he's claiming here that if a classical macroscopic apparatus, depending on the aim and end, can sometimes be regarded as a quantum object, sometimes not, then it seems to me that it is really not stressing that this distinction thesis has an ontological meaning. But then the consequence is, I don't know whether this makes any sense or not, the same object S must be regarded as classical and quantum in different experimental circumstances, which entails for me the problem of the identity of macroscopic objects. Because if the system S plus springs is different from S plus bolts, then S has no intrinsic identity. And if it doesn't have an intrinsic identity, unless it's considered with the agents of observation, now my question is, the purely relational identity of macroscopic object in QM seems to be ad hoc, as it does not cohere with our ordinary understanding of properties of macroscopic object. We do not think as being completely relativizable to other objects. So we have this idea of substance that Philip was after somehow. So now the fourth, I already presented this. The characteristic new feature in quantum physics is merely the restricted divisibility of phenomena, which for unambiguous description demands a specification, again, of all significant parts of experimental arrangements. And so, other quotation, the essential indivisibility of proper quantum phenomena, a feature of wholeness in the atomic processes. And here, the only significant point is that in each case, some ultimate measuring instruments must always be described entirely on classical lines, again, must be kept outside, despite this holism. The system subject to quantum mechanical treatment. And finally, this is the usual and somehow often repeated criticism. It seems that the necessary assumption of this distinction thesis prevents a constructive explanation of the emergence of the classical from the quantum, especially because Bohr defends a physical theory of measurement. These are quotations which I'm sure you will be familiar with. Finally, uncontrollable interaction between system and apparatus that is not further describable from a dynamical perspective, since it's talking about interaction. This is a physical interaction. And then it's also about suitable amplification devices with irreversible functions, such as, for example, permanent mass on a photographic plate. And I think it's completely against the idea that probability is a degree of belief stuff, because it refers to frequencies, and my friend Jan Fay found and provided me for some references here. But then, to the extent that only constructive explanations provide understanding, as Einstein was claiming before, then this distinction thesis betrays the persisting aim of physics, which is to understand the world. Now the question is, can we understand the world only with a constructive approach? This is the typical objection. It is hopelessly vague. If what to regard as quantum or classical depends on the observational context, the ontology is arbitrary. This is just a summary of what I just said. Now the possible responses that Bohr gave and could have given to these 5 difficulties. One obvious position is that this sort of combination of DT and nonseparability is just epistemic, so it's a condition of possibility to attribute empirical meaning to quantum mechanics. And I will just relate to Stroesson's wonderful quotation that I found. So, ontologically speaking, everything is quantum, but if we want to somehow resolve the problem of observing a definite world, we have to assume that this distinction thesis is just epistemic. And then, of course, there's reference to shared language, which prevents criticism from those that claim that basically subjective states or mental states are unavoidable if we want to make sense of quantum mechanics. And of course, phenomenological approaches in my mind are not subjective in this sense. And this is the problem that I was mentioning before. The quantum system interacts only with a part of the classical apparatus. And decoherence, I'm not going to present it. I'm sure everybody is familiar with Howard's approach. And this is my proposal. Quantum mechanics is a theory of principle, so far, so that constructive approaches are not explanatory indispensable. It would be much better if we had approaches like this. I think GRW is a way to proceed. There's contacts with experimental possibilities. Well, ordinary language is necessary and sufficient for objectivity and communicability, and this is Strawson. There is a shared and universal conceptual scheme which we human beings have, and know that we have, and for which no justification in terms of more fundamental concepts or claims can be given. It's a sort of move that has been already presented by Harald. We can explain your experience on classical concepts using the quantum mechanical language, because this explanation would require, in its turn, our experience in classical language. I think it's a conservatory attitude. And this is a quotation from Bohr in 1985. Not all of the experimental arrangement has to be considered in direct interaction with the quantum system. So he seems to be able here to solve the problem of the nonseparability only in the significant parts of the experimental arrangement. This is what makes it possible to consider that the watches and measuring rods, here he's referring to Einstein, are outside and independent of the object under consideration. Let me skip here, Landau and Lifshitz account, which is, I think, somehow, let me just quote this. In order to describe the trajectories of atomic particles, one needs apparatuses that can be regarded as classical. And the track in the Bumble chamber is classical to the extent that it's very large with respect to the electrons, so that the latter becomes a quasi-classical object. And here is Henrik Zinkernagel's elaboration. The atomic entity interacts and is entangled only with the part of the instrument. And there is no entanglement between quantum systems and micro-instrument, but how are we to distinguish which part of the classical object is relevant here from the whole? How big must the part be? And so the distinction thesis seems to me strikes again. There is an approximation here. I'm going to skip Howard. This is modeling famous challenge. If we assume completeness of quantum mechanics, linearity of the evolution, and definite outcomes, we have a contradiction. So, should we or ought we to explain in constructive terms what these physical interactions are, which Bohr refers to? And this is what I'm trying to claim. For Bohr, quantum mechanics is in some sense a theory of principle. I'm trying to use here the quantum postulate and the light principle as analogous to, as constraining principle. And the question is, and here I think Federico will have something to say, is the quantum postulate a meta-law in the same sense in which the light principle is a meta-law? And here is my conclusion. Principled theories and constructive theories express two different stances about explanations. So what is the aim of science, basically? I found this quotation where it seems to me we can find evidence that Bohr indeed thought that the quantum theory, the quantum postulate, has some sort of incredibly close analogy comparison with special relativity, or purely logical aspects of relativity and complementary argumentation reveals striking similarities regarding the renunciation of the absolute significance of conventional physical attributes of objects, and that's the part. The neglect of the atomic constitution of the measuring instruments themselves is equally characteristic of the application of relativity in quantum theory. So he's thinking about the fact that Einstein was really in an embarrassing situation and just went with the principal theory, given the construct between continuous and discontinuity in electromagnetism. And velocity, spatial and temporal intervals are, of course, frame-dependent, and are not intrinsic absolute properties, only the four-dimensional description of space-time is, while position, momentum, energy, time are state-dependent. So somehow there is an analogy here between this relationality of STR and quantum mechanics. But there are, of course, state-independent properties like mass, spin, and charge. And I never understood how French and the structural ontological realists treat these intrinsic properties of the quantum entities. And this is, of course, the correspondence between this rational generalization of previous theories that basically makes it the case that the precedent theory is a special, particular case. So a rational generalization of classical physics which would permit the harmonious incorporation of the quantum of action. In relativity theory, the separation between time and space depends on the smallness of the rate V over C. In quantum theory, the appropriateness of our usual causal space-time description depends entirely upon the small value of the quantum of action. So it seems reasonable here to claim that there is some progress in science because the successive theories generalize the previous theory as the wave theory of light generalizes the corpuscular theory of light. And that's the best destiny that physical theory can have. There are some other analogies in here. I hope there's going to be some criticism. They involve universal constants of nature, both principle, which enter the most fundamental physical laws. And of course, here I'm referring to quantum gravity. By constraining what can be known of the physical world, H because of its discreteness, C because of its finiteness, they are universal empirical generalization of principle that all phenomena must satisfy. And it is not, I think, the quantum postulate is not just a formal requirement in the sense of the special theory of relativity and the covariant requirement, which is also completely devoid of physical meaning, but it's a fundamental conceptual structure of any measurement interaction. That's what he claims. Every measurement presupposes an interaction. Every measurement creates a non-separable joint system. Every measurement obeys Heisenberg complementarity. And every measurement presupposes its arbitrary operation. So to the extent that measurements are physical interaction, as Bohr claims, the quantum postulate is a meta-law describing all of them somehow. It's a different beast here because Einstein thought that the relativity principle was an attempt to symmetrize what happens in physics, because physics is something that strives toward invariance, and we don't want any theory to be dependent on a viewpoint. So objectivity is invariance, basically. I think I went beyond. I found this quotation, which I think Einstein knew about. General laws in principle, thermodynamics, conservation laws are prudent. By neglecting the inner constitution of bodies, they apply to a wide variety of phenomena, but are only partly satisfactory. I think Einstein was familiar with this because it had been written in 1900. But theories looking for mechanism of the appearances, and of course referring to Kelvin's vortex theory, which is a mechanical way of explaining what electromagnetism is about, they broaden our understanding of particular physical system, but are more daring. So there is an epistemic risk in choosing this attitude and this attitude. But this attitude, believe me, I think it's an important way of defending the idea that explanation in physics entails unifying phenomena. And this is the part that I'm using, ex auctoritate. There are multiple ways by which we try to understand natural phenomena, individual characteristic. Any inclination determines the choice of each scientist. And I think this position takes care of Federico's complaint, well-justified complaint, about the fact that there's no explanatory priority of the kinematical over the dynamical approaches to quantum mechanics. So I think he's right that it's unwarranted, but now we can be more liberal, the principle of tolerance, and we can actually accept that both explanations are acceptable, and I think it takes care also of Boob and Petoskey. Quotation here, there is no deeper explanation for the quantum phenomenon of interference and entanglement than that provided by the structure of Hilbert space, just as there is no deeper explanation for the relativistic phenomenon or Lorentz contraction and time dilation than that provided by the structure of Minkowski's spacetime. But I think this is sort of a dogmatic viewpoint. We shouldn't prevent physicists to search for constructive explanations. So it's a matter of risking your epistemic attitude, I think, as well. So the current disagreement between the principal theory and the constructive theory camps is a matter of epistemic stances. the theory's predictive core can be given both constructive and principal theory explanations. And so we should just let 1,000 flowers bloom. That's it.
Thank you so much.
Yes, Guido. Oh, okay, so this is really encouragement for me. You know how much I respect you. Federico. Too many quotations.
Anyway, no, my question concerns your idea that quantum postulate might be
a principle
as a meta law. No, the problem I have is that the idea of a meta law is something that constrains the form of the law, the kind of strictures about phenomena and so on, whereas in this case, as in the case of the velocity of light as a limit velocity, I mean, there are brute facts that we discover they play a certain role with phenomena. So a statement concerning, in some sense, a fact of nature, like the existence of quantum action or the existence of limit velocity, do not seem to have the form of a meta statement. They are statements about the certain way in which nature is. It might have been different, but this is the way it is as we discovered it. So meta laws are, in my view, should be at a different level. So I have a problem with this.
Yes, I think it is hard to understand what a meta law is, but it seems to me it's a law that tells us how we have to formulate the lower level laws. So if you bring in the relativity principle, you introduce some symmetry, which is somehow to be expressed in a formal way. So covariance and where relativity, Lorentz invariance. But there is a sense in which the quantum postulate somehow imposes a conceptual limitation which is expressed when we talk about a measurement. But I agree they have a different role. But I mean, we had evidence that there was independence of the velocity of light from the velocity of the sources emitting light. So there is some sort of empirical evidence that Einstein had before. But that's an axiom of the theory which has so many counterintuitive consequences against common sense, because that was the only way to explain the fact that you cannot measure a difference in the velocity of light in the Michelson-Morley experiment. So you have to change your idea of space and time in order to make sense of the theory. But there are difficulties there that you're pointing to, which I think I should have clarified more. I was trying to push my point.
Do we have any further questions, comments, remarks? So maybe I have, and I think it's pretty much following the line of your question. I mean, could you perhaps elaborate a little bit with these examples between meta law on the one hand, and for instance, how Cassirer looks at covariance as a quasi-transcendental of the possibility of objectively given a certain theoretical claim?
Yes.
That be clarifying?
Yes, of course, Cassirer, I think, was familiar with Kretschmann 1917 criticism of the fact that covariance principle has a physical meaning, it's just a formal requirement. And I think Cassirer thought that the idea of invariance that he interpreted as a group symmetric requirement, it comes from the Klein-Langen program. And I think that that's a regulative principle that he insisted upon. And in this case, I think there is a difference. There is definitely a difference between that sort of invariance requirement, which is actually so important in both quantum field theory and general relativity and special relativity. So here I'm a little bit forcing the case because I want to try to insist that there is some sort of conceptual structure which is somehow more general than these single statements. But yes, I mean, there is a difference there. I agree.
All right, let's give our speaker a big round of applause.